So let's get started with Paul. We'll give him a round of applause.
Thank you.
Just click on to the next one, make sure.
Hello. Thanks, Mark. So everyone said I'm Paul Reardon. I'm a principal engineer at Flagstone, and I'm a maintainer of an open source project called Brighter, which is a CQRS framework. And I'm here today to talk to you about open telemetry and, well, generally how we're going to use it in today's distributed landscape. So let's talk about the landscape we all live in at the moment. Back when I started in tech, everything was a monolith. You know, big servers, things running in a single location. And this did make some things a bit easier when we talk about it. I remember some of the first systems I worked on, they didn't have much in the way of logging. Some had a rolling text file. I've had a fair few things that are also into a database or many other forms of logging. But anyway, today's landscape, as I've said, is not centralized. And more, it's not even written in a single language. You know, when I started, even when I moved to the UK and started at Flagstone, everything was C# and MVC. Not anymore. We now have React, we have TypeScript, there's some Salesforce in there. And more companies are picking whatever language is best for the job as opposed to choosing, you know, I want the Microsoft framework or something else of that. And this also leads to one of the other big things. Nothing's on a single machine anymore. You know, we've gone to Docker containers or microservices, generally things like Kubernetes, VMware, everything else of that nature. So when we actually think about what we need in terms of logging, in terms of telemetry, and more importantly, how to work out what went wrong when something went wrong and get to actually fixing it, it's not as easy as it used to be. You know, everything's not in the context of one machine. Everything doesn't happen synchronously anymore. So this is where open telemetry and observability comes in. Observability being the bigger thing. So what is observability? Observability, quite simply, is being able to ask a novel question about your system and get an answer. You know, this isn't that we wanted to know this answer when we developed the code, but someone said to us, how many orders did you place today after 3 p.m? Or how many orders were on an odd minute? You can get this from your telemetry, things you wouldn't think about. You know, during what sort of order did your CPU run hottest? I don't know why you'd really care about that one, but if you did, this is the place you're going to get it. And there are 3 pillars of observability: metrics, logs, and traces. So my best way of explaining it is imagine you're driving by car. Imagine you're on a journey. Metrics are like the car's dashboard. They're showing you the speed, the fuel level, the engine temperature. They give you an overall sense of how the car's running, how the journey's going. Logs are like the driver's notes, right? They are recording specific events with some detail. I started the engine at 9 a.m. I stopped for fuel at 10:30. I encountered a bumpy road at 11:15 a.m. And traces. This is the new great thing in telemetry. They are like a GPS track of the entire journey, showing the exact route taken and time spent on every segment of the journey, any detours you may have taken or delays or ways around. And this is what we're really here to talk about today. So, unraveling the journey and the importance of tracing. Traces are what's been missing, as I've just said. They're the big thing that brings here, and it's generally what we want or what we need as part of this. A trace is a representation of a single journey as it traverses through our system. So if you think about that as a car analogy and you think about how your distributed systems work, it's not, you know, you click your button on MVC and all the code runs in a code bind and it's done. Our journeys are a lot more complex today. So yeah, this is what a trace is, sorry. When errors occur, traces can pinpoint the exact service that the error happened in, and they can give you some details of what came before, what came after, what happened at the same time as that thing failing. Was there a retry? Seeing all of this on a single pane of glass is what we really want to get out of this. And traces record the time spent in each service for each operation, allowing you to identify latency, bottlenecks, performance issues, other things like that. And another thing I've found really useful for tracers myself is you can enrich them with important data. One of the things I'm always cautious of saying is I like to wrap some of my repository patterns in tracers, and you can put your database query parameters, assuming they're not PII and they, data that can actually go into logs there. But I've found this really useful, and I'll go into why on a later slide. So I created some code. It's terrible code, you don't want to see it, but here's the output of that code. I've used an open source system called Signos, which is just a system that you can seam and export all of your open telemetry data into. And as you can see here, I've created a small trace. Let's picture this as a web store, right? And on the web store, as you can see, there's an API. It's an asynchronous API, so you don't expect it to do much in there. It puts a message on the bus for someone to work out later, and they can post to get status. We have something called the orders worker. This processes the orders and things around the orders. And of course, what's a good store if it can't bug you with emails? There's a communications worker on top of this, right? Standard distributed architecture. And as you can see here, the user, they posted to orders. It happened there. Then, just before this trace started, we picked up a message and the order worker started processing the command. That happened. I'm assuming it went well because we now fired off 2 other processes, which is the send order created email and the process payment creator email. This is obviously off the order new version event, let's call it, for lack of a better term. 2 subscribers here. And then I'm assuming this either worked or didn't because there's a new order new version event where the communication worker comes back in and sends an order updated email. So standard distributed trace, and this is all plug and play out of the box with Signos and the OpenTelemetry framework. I did this in .NET, but to be honest with you, the whole point of OpenTelemetry is who cares what I did it in? One of them could have been in Go, one of them could have been .NET, one could have been Rust. Pick your favorite. Now, let's just go through metrics a bit more. So the whole purpose of metrics, it's to answer the question, how is my system running? That gives you key insights into what's going on in your system. It can tell you that there might be a problem. And when I say might, maybe things are taking longer than they usually take. You could have high latency. We'll look somewhere else for that. Maybe less orders are being placed in my store. Maybe I have access issues and that's why less orders are being placed. Maybe my servers are running hot, burning up my serverless credits or whatever you want to call it, high CPU memory use. The thing with metrics are they don't usually tell you why there is a problem, but this is okay. They don't tell you why the request is slow or why the system is running the way it's running, but they're a really good signal or indicator to tell you there could be a problem. Obviously, with all metrics, logging, scanning, things of this nature, you need to set a baseline for your app. And once you've set the baseline, you have acceptable limits of where I expect my orders to come in. And you can then actually use all of this for triggering alerts. So metrics they're not just about the tech level things. As I said, having a business metric like orders placed, orders completed. Time order took from be placed to shipped. These are all metrics you can follow, and when you start to fall out of acceptable limits, you can have an alert to get someone on that. I never like it when I find out about an issue from someone calling me. I want to know about the issue before I have a user on the phone or a business person on the phone telling me there's an issue. Logs. My good old friend logs. The simplest, most basic way of logging, what a great way to put it, of actually getting data out and working out what's wrong. I've seen every form of log in my time, from working on embedded systems to having a blinking red light. One of my favorite ones you could argue is back when I started building computers and you got the beep for BIOS post, or multiple beeps for RAM's not in correctly, or whatever we had, right? But back to logs, they answer what happened at a specific point in time. They're, one of the oldest things we've got here. They're generally time series these days. I really hope they're time seriesed, and they're generally also categorized by severity. Helps us filter, so I care a lot about criticals. I don't care so much about debug and trace. unless I'm really trying to dig down to them. One of the biggest things that logs don't give you is they don't inherently link together. You know, if it is a rolling text file, who knows what's put into there? Maybe one system flushed at a different time than the other. You've got the time sync for that. But you don't know that the log below the other one is actually even related to it. Maybe it's off of a different trace or off of a different actually request flowing through the system. Obviously, there are tools you can get to try and sync that, but it's not, the logging framework isn't made for this. This is all things we've done on top over the years to try and get us extra from it. So yeah, correlating logs from different services, that's going to be fun. If we talk about what I've just said there, if I have a log file for my API and a log file for my communications worker and a log file for my orders worker and a log file for the 30 other microservices I've decided to develop because that's how I've architected my system, how do I make sense of all these data sources and get them into one when they were never actually built to work together? And one of the other things I want to touch on here is realistically, in my experience, logs tend to be noisy. And as anyone who's worked in a cloud environment or anywhere where they're paying for things on a subscription basis, noisy often correlates to expensive. And a great example I've got is the ASP.NET Core informational logs. I've recently undergone a project to filter out all ASP.NET Core informational logs. For those of you who don't know what is in this log, for every web request, there's generally a web request started log and a web request finish log and a web request was successful log and a authentication happened log. You can get all of that information from a trace. A trace has start time, end time. I don't need 4 lines of logs. And one of my favorite things that happened, apart from saving a decent amount of money by just not putting these into our logging system, is now when I actually go to look at my dashboards, at my logs, I'm looking for a problem, I've got about 8 lines less of logs I have to ignore. I've removed the noise. And realistically, when you think about being an engineer, there's a lot going on these days. And when you actually want to know what's wrong, you just want to see the issue. You want to get to the problem. You don't have to go, I don't need to care about that line, or that one might be important. No, it's not. And if I get all that data from the trace, why would I pay a ton of it, 8 lines per log per web request, 20 web requests a second on some systems, maybe more, across multiple microservices? I promise you that adds up to hundreds a month. If you're lucky, it's only hundreds a month, to be quite honest with you. Now, open telemetry, the thing we're all here to talk about. The whole purpose was to unify telemetry. As such, it is vendor and stack agnostic. It's here to standardize interoperability. Realistically, what is it? It's an API and an SDK for implementing in your code and a set of collectors for processing and exporting data. It is a standard that everyone seems to have agreed upon, which is great. It avoids locking you into a specific product or platform. So I said, I work in Microsoft most of the time. As I said, I use Signos for this demonstration. I've never used Signos before. I use App Insights at work. But I wanted to see what was out there. Signos, for those of you who don't know, I found doing a basic Google, but its tagline is trying to replace Datadog. It is just a system you can use. I could run it locally using a Docker Compose, which made it really nice for my test. And all of the screenshots you'll see around here come from it. It was very easy to set up, and thanks to open telemetry, very, very easy to just seam everything in. One of the other big things, which I'm sure everyone in this room is probably really passionate about, it's community driven. It's a growing ecosystem of community driven. Everyone has a say. Everyone can actually, talk on a GitHub issue, on an RFC about the way we want things to go. I think a lot of things have been ratified already, so it may be a bit late to get too much change in there. But if there isn't an exporter for your system yet, you can write one. But there is also an open standard if you don't need a straight exporter. And one of the biggest things for me as a maintainer on Brighter, because whenever I want to bring something in to a project like Brighter or anything I write, I don't want to bring in extra dependencies. I don't want to make opinionated decisions for people where my product, my library, it's not a concern, right? And Brighter being a CQRS framework, I shouldn't really have an opinion about how you should do telemetry. I should have an opinion about CQRS. And before we had open telemetry in Brighter, yes, we had a iLogger logger exporter, but we didn't have rich telemetry built into Brighter. And when you think about the idea of traces, and you think about all the lovely things that the likes of Dave Fowler's done in ASP.NET Core that we all completely don't know that's there or forget about, the only reason why App Insights works so well with Microsoft is because there's a lot under the hood that Mr. Fowler's done for us. There's the starting of the traces and spans, the finishing of them, the error handling, all of these things that when I started before ASP.NET Core, you didn't get. And I remember the days where if you threw an error and no one caught it, your program crashed, not it returned to 500 and kept running. And the thing here is, because OpenTelemetry is an open standard and I have locked no one into anything, we brought OpenTelemetry into Brighter, which now means if you want to use Brighter as your library and you want to go out to App Insights, that's great. That's a line of code for you. You need to bring in no extra dependencies. If you want to go to Signos, the exact same way. If you want to go to Datadog, great. If you want to use Jaeger for distributed tracing and something entirely different for your metrics and your logging, it's a no-brainer. We brought it into Brighter because everyone's agreeing on it. It's an open standard and you can now use whatever you want, as opposed to having to maintain a package for every single collector you've got and have a agnostic way of actually bringing all the collectors in. And for me, this is one of the biggest things about the open telemetry itself. Obviously, I'm passionate about observability because I want my systems to run well. I want to know in ahead. So I want to know ahead of issues and I want to be able to diagnose things really quickly. But open telemetry gives me the ability to bring these things into my library so you can now have first-class telemetry inside my library without you having to think about it. And it means other people who are now developing libraries can give you this telemetry without having to think too much about it. And now that we have our telemetry, it's all together, it's in there, what are we going to do apart from pay the bill? What is this bill actually getting us? And realistically, it's getting us a lot of data and we want to get some actionable insights to it. So what insights do we think we can get from open telemetry? There's performance analysis, identifying slow services and operations for things that happen in the real world. We've all heard it worked on my machine. It's fast on my machine. This bug didn't happen. How do I recreate this bug? It was really performant in my local database that is entirely different to the one hosted in the cloud. How do we actually get this working? Error debugging. Something went wrong. I've got a ton of servers out there. What's happening? Server dependency mapping. This is one a lot of people don't think about, but when you're thinking about BCP and DR exercises, if one point fails, what's it going to affect? Well, if I have distributed tracing and all this turned on, I can just say, what are my dependencies? Here's a graph. Goodness, sorry about that. Here's a graph, it works. I can now actually get data that I didn't think about. SLA monitoring. I can use this data to say, what's my 99th percentile? What's my 95th percentile? What's my average? How quickly am I returning? How often am I failing? And another thing, as I said before, I like to create traces around parts of my infrastructure that are important, or parts of my code that are important. Repositories is one I've brought up, which I'll walk us through in a minute. But if you wrap a repository trace in there, you can then actually get some really actionable data. And I hope my next two slides will actually show you how quickly and how powerful this will be at spotting a performance issue. One other thing I want to talk about, I touched before, metrics. If I was to ask two metrics that everyone in this room's heard of, I highly reckon it will be CPU usage percentage and memory usage percentage. They're metrics or counters that have been around since the beginning of time. And you get a lot of infrastructure metrics for free because we write software here, we don't build infrastructure. Now, one of the things that I'm big on here is actually getting actionable insights. You heard me before talk about order placed. Having that metric come up, having something that your business might actually care about, that you could put on a screen in your office or a dashboard in your office to show a graph and to show in the last 30 minutes we sold 30 things, 30 widgets, if you will. It's useful for you because you can get a baseline. It's really useful and easy for you to mine and give to your business because it's data they understand and care about, and it can really bridge both of those two things. So let's get into using traces to diagnose performance problems. So exact same scenario we talked about before. I have a user who's placed an order and the payment's gone through. As you can see here, do note this does not add up to 100%, but that is entirely because it is percentage of whole time, and because we have distributed systems, we have, well, while we have 3 services, they're also multi-threaded. So as you can see, many things are running at the same time here. But 2.28% of the overall elapsed time was the API. As I've said, it's an asynchronous API. Maybe that's a lot. We'll look a bit deeper in a minute. The communications worker, 26.29%. That's, not where most of our time's spent. But as you can see here in the orders worker, this is taking up a decent percentage of my time. Let's see if we can spot a performance issue when we dig into what's actually going on here. So as you can see, the store API, post completed in 51 milliseconds. I don't know about you, but I'm not upset with that performance, to be really honest. Order created command, 903 milliseconds. That's not really where I want it to be. Okay, what did we do? We have a repository span, get user by ID, 529 milliseconds. I'm not loving that. Create the order, 98 milliseconds. I'm not loving that, but nowhere near as much as I'm disliking this one. Anyway, as we know, that created an order new version event, and we've come to process payment here. Process payment took 1.33 seconds. It's asynchronous. I don't love it taking 1.33 seconds, but for a command that doesn't directly affect users, let's see how we go. Database, get user by ID again, 500 milliseconds. Well, I think that was quick to work out where the first performance problem I'm going to be looking for is. Get order by ID, 232. I don't love it, but I've got 2 of these, a large amount of times that I think we need to look into. Now, one other thing I'd like to talk to before I go to my next slide about this is why I've wrapped my repository in a trace as opposed to just using my dependency to SQL. And for those of you who haven't thought about this too much, and I mainly have because it's bitten me at least once before, if you think about the process of you going into SQL, getting your data, bringing it back, and making it usable. I mean, there are more than 2 things going on here, but if you'll forgive me, there are 2 things going on here. There is the performance of your SQL query, and there is the boxing of your data into a usable object inside of your class, right? So I have seen it where in 100 milliseconds, we've returned 1.2 million rows. And I've then seen it take 10 seconds to turn that into something usable on my computer. So if I just had the SQL trace, I would have seen 100 milliseconds, nothing's wrong here. Nothing's wrong, I don't have to touch this. Now I've wrapped the entire trace. That's from when I've asked for the data to the data was actually usable in my system. So I now know that I need to look into this. If I have put the user ID, assuming it's not PII, not an email address or something of that nature on there, I can grab that, generate the SQL query, grab a profiler, see what's happening in there and also run the query against that database and go, oh, there's 1.2 million rows. Maybe I need to filter because it's a user, there should be 1 row. Or maybe my query is really, really not optimal. I need an index on there or whatever it may be. And for me, this is the power of actually wrapping a trace there. This graph quite quickly shows there's my performance issue hitting me in the face. I didn't even have to dig into it. Anyway, that brings me to the end of this. Is there any questions?
You mentioned about the writer.
Yep.
What you said, is it CRQS?
CQRS, yeah.
CQRS. What does that mean? What's the acronym stand for?
Command query resource segregation. So if you think about things like Mediator, I think Mediator was actually the one that took from Brighter first. We were first. Yeah, so CQRS being a way of splitting your reads and writes. So you have your commands being go do a thing in your system and your queries. So you can split the repositories. It's a really nice pattern for how you actually do these things and allows you to use different stores. I'd highly recommend coming to Brighter. If you're going to an event-driven system, it's a nice framework that goes around it. And from V10, which I think will be out in a couple of weeks, OpenTelemetry is native. Ian Cooper's done a lot to actually bring in semantic conventions on OpenTelemetry as well. It supports multiple different transports out if you're worried about it being agnostic. So we have, I think, Kafka, RMQ, SQS, Service Bus. I'm forgetting about 6. Multiple different outbox patterns as well if you want that. Yeah, we'll see. I'll put something on LinkedIn about where we can go look for Brighter if anyone wants to know more.
So OpenTelemetry isn't like a package that you install. It's a standard which Datadog and...
It is an industry standard.
Yeah.
And everyone, I mean, even Microsoft are moving to it.
Yeah.
So all of App Insights is now OpenTelemetry native. ASP.NET Core has gone OpenTelemetry away from App Insights specifically. Over the last year, I actually removed all the App Insights code from my apps and just made it OpenTelemetry. I don't see us moving away from App Insights anytime soon. Lots of data there, and you'd need another good contender. But what this means is if I wanted to, I can. Aspire, .NET Aspire uses OpenTelemetry for all its dashboards. From what I can tell, most of the industry is built into or is moving this way. And so the biggest thing for me is you now have a system that you don't really have to rely on plugins or other things for. It's just a standard that everyone's adapting. If I was to go to the hardware world, similar to USB.
And sorry, last question. The actual, like when you're talking about wrapping a repository back to the trace,
Yep.
what does that actually look like?
So a trace or a span is effectively each part of the journey if we talk about their GPS. And they all have, well, apart from the first one, parents. So in .NET, it is as simple as using an activity source to go create activity, and then you just dispose of the activity, set it back to where it was. As I said, things like Brighter will do this for you. One of the things about distributed tracing and all the libraries having it is as the message flows through the system, a lot of the Microsoft libraries, I talk about Microsoft because it's what I'm most familiar with, know that there was a header that's come through on the HTTP request or something that's been put on the message off the bus or whoever's come through to go, this was my diagnostic parent ID, and it sets the new one up. And because each trace has this as my parent, if your Signos or your trace provider or whatever knows about that parent, it'll just stitch it all together for you. So if I come back to here, these 3 systems, I'm going to say they don't know about each other. What I'm going to tell you is I shared the contract between them in .NET. There was no need for all of these to be .NET. There was no need for them to even be running on my machine or anything else of the nature as long as they're exporting to the same exporter.
You need some kind of unique ID for that then.
It'll create it for you. So when you create a trace, it will just do it for you.
But what if you've got two microservices?
Yep.
How do you ensure that they're both going to output that same locator ID?
Sorry, you mean when they start going through?
Yeah.
So realistically, I have 3 microservices here. If I go back to this one, 3 distinct different applications running different ports, different processes and everything. So this one was over a bus, and the framework knew that one of the headers on the bus, which I've used Service Bus for this and the Service Bus emulator, we finally have an emulator for it. That put the Microsoft package automatically put the diagnostic trace on, and when it pulled it off the other end, it knew to take it off and then link it up. The Microsoft HTTP clients do that for you as well. They put the correlation ID, if you will, in the header so it comes through, or the activity trace parent. So it knows when the next one picks the thing up, whatever called it, whether you're dequeuing from an API or not dequeuing from an API, listening from an API, dequeuing from a queue, or whatever else is coming, the thing that actually pulls it off needs to know to put it on there. But I've seen most big frameworks these days are doing that automatically.
You touched on it a bit earlier, but do you have any recommendations on managing cost?
Be observant.
Yeah.
So one of the things I've talked at Flagstone about quite a bit, especially when you're starting out on your cost journey, well, generally this happens when someone goes, why is my bill so large? I'm paying how much for what? So for App Insights, right, it all goes into log analytics. And what I generally do is I look at the ingestion and then it splits it by table. Tables being your traces, your dependencies, your requests. I look at the bigger one, and then when you select from that in KQL, you can see the type. And if you just do a summarize by type count, you'll see where most of your money's going fairly immediately. But also the other thing is, as with all telemetry, sampling. Do you actually, what are you using your telemetry for is my question. Are you using it as a system of logging? I'd suggest that's not maybe the best idea, not what it was built for, but do you actually need to know about every single request that's come into your system? Or is knowing about 80% enough? Or is knowing about 80, 100% up until I've hit this much data and then 20% after that enough? You don't necessarily need to bring all your telemetry in. There are many different types of sampling you can do, but generally I'd look at it, I'd keep filtering, I'd look at my logs, I'd look at my traces, and as I did with the ASP.NET Core one, see what's useless to you and what's useful to you. Those ASP.NET Core logs, you get them for free. They're turned on generally for free. I also found them to be overly useless. I've yet to see an engineer say, well, where did that log go? I really miss knowing that this request started and ended. I mean, we've already got that on the traces, I've said, and it's going to be the same thing with traces. If you wrap everything in your system in a trace and you store every single thing in a trace, you're paying for that. So it's about thinking about what's important to you. And if it costs nothing, we'd wrap everything. Well, you wouldn't wrap everything because that would make your system slower and you'd have a whole host of different issues then. But in theory, if you wrapped absolutely everything, you would keep it all in there and you could see each bit of the code, and it would make it really easy for you to find a problem if you didn't drown in noise, which again, noise is the biggest thing. I've worked both as a sysadmin and an engineer, or a developer, I should say, and anyone who's set up SCOM for the first time, just get ready for that flood of emails when it tells you about anything that's happened on your estate ever. This thing's all about tuning, all about watching what's going on in your environment and talking to your engineers, talking to your colleagues and going, what do I care about? Do I care about this log? Do I not care about this log? And then sometimes it's a business decision. This log, I think this log is super important. However, we're getting 100 million of them a day and it's costing us $1,000 a day. And then you have a conversation with the business. I think this log is very important. It will help me when this, or this happens. Do you think can I have whatever number that's going to cost a day for this? Everything's a decision, right? Is it important enough to actually placate the costs and have the costs agreed?
Quick one. Have you seen observability used as like a testing strategy or as part of the testing strategy?
I haven't, but one thing I suppose I should have touched on that I didn't is test your observability when you write it in your libraries. If you care that your metrics there are many testing strategies, I've done them all. If you care that a trace happened, test it. If you care that the metric was spat out in the correct way, test it the exact same way you would test actual code. I'd be interested to hear how you think it could be used, but you very much could do it.
If you go back to, was it the next slide? I can't remember. One of the ones where you had the whole trace with the APIs like that. You've got kind of events there. You could do like a regression test pack over that.
You very much could, but generally when I test distributed systems, I try and actually constrain my inputs and outputs. Because obviously the biggest problem is when you're testing a microservice or distributed systems architecture in here, you don't know, like, we ship often. We ship frequent, ship often. And the biggest problem is when you develop, you don't want to be developing against a developed version unless you have to. So if you have 50 services and you want to change one service, you want your other 49 dependencies sitting around it to be production. When you think about it, if you're developing against Active Directory, I don't even think the people at Microsoft are developing against the development version of Active Directory. They're developing against the production one. You don't develop against a development version of SQL. You may call that instance development. It's production. It is a production-ready one. Because what you really don't want are false positives or false negatives when things run through. So my testing strategy generally would test around individual services where I know what's coming in and out, as opposed to, I mean, I'm not saying don't have a test that runs through the same thing, but in the pyramid of tests, a test that runs through the same thing would sit way up the top for me.
Great. Thank you very much, Paul. So Paul's going to be running off quite quickly. So if you do have any more questions for him, you've got probably about, what, 5-10 minutes before you have to run? Oh, 15. Okay. So you can grab him. So I won't keep you long. We're going to have a break now, but just wanted to remind you of our supporters, Bournemouth University, for giving us this amazing lecture theatre. Thank you, Finn, for organising that for us. Thank you. Allowed us to be here tonight. Reconnect conference, which I'll jabber on a bit more about later, but if you want to know, come and see myself or see me over there. Wave enthusiastically, see me. There you go. And Just Pick One UK, which is this really cool YouTube channel that you may or may not have heard of. If you haven't, check it out. I hear it's really, really good. Kerry's YouTube channel. So let's have a break. We've got about 20 minutes. Speakers, can I borrow you for a minute, please? There's drinks over there, snacks. Talk to each other. So we're going to get started again with our dynamic duo here, Ganesh and Dayton, who are also from Flagstone and also from London, like Paul was. That was entirely coincidental, it was not by design. And they're going to talk to us about this, which I'm not going to say again because it's got a lot of words.
A lot of words here there.
So hopefully we'll know a bit more afterwards.
We'll make it easy here.
Great, thank you.
Thank you.
Thank you. Okay, so hello everyone. Today we'll be talking about how to solve a very complex problem in Salesforce using a industry-proven clean architecture principle. So essentially, we'll be architecting for the complexity, and we'll be taking you to the whole journey of like how you can, defining the complex problem, how to solve it, how to come, and then actually showing it in the code as well. Quick introduction. I'm Ganesh Tambat, senior software engineer with a passion of building maintainable, scalable, and user-centric solutions using Azure and .NET cloud technologies. This topic today is essentially I've driven from my experience of working in both these fields together. Dayton?
Yes, my name is Dayton Meyer. I'm a 4-time certified Salesforce admin and developer. My focus is bridging business needs with technical blah, blah, blah. Basically, all this means is like we like to have fun making stuff and hope it doesn't break at the end of the day. When I'm not coding or working on Salesforce stuff, I love travel, motorsports, photography, just spending time with my wife and dog. Yeah. So we are here today to talk about Salesforce and talking about complex implementations. Simple implementations, I'm sure we're all aware. These are very easy, clear scope, few automations, nothing too complex, using point-and-click tools, very easy to build. But today we want to talk to you guys about like using multiple integrations, custom logic, lots of dependencies, things that require modularity, that are loosely coupled, that need scalable designs. So one way that we're going to use as an analogy to get through this today is a taxi driver taking customers from London to Madrid. Kind of not an easy thing to do, but stay with us. It's going to make some sense. So sorry, this is you. I'm getting too excited.
Yeah, no worries. Thank you. So yeah, so before implementing such a complex, to start implementing before such a complex, solution, what you have to essentially do is 3 different things. So there are several key aspects that has to be established. The primary and the most important one is understanding the core domain itself, like deeply understanding the problem itself, and then investing time in domain modeling, and then clearly having that mental map of the problem that you're going to solve. After you know the problem you're going to solve, you then start discussing with the right stakeholders, and then you start defining the most priority use cases, right? So once you do this together, this is essentially becomes your application. That's what you're trying to solve through your application. The next thing that comes up is the structure, right? I mean, how do you structure your application? And the rules of the application, which you will derive from understanding the core problem and the use cases. So once you understand the application, you now have to fit that into the Salesforce structure itself, right? But before we go dive deep further into that, let's just understand what Salesforce is. In our analogy, it's like the car itself.
Perfect. Thanks, Ganesh. Now, okay, so Salesforce is really cool in that it offers a couple of different applications. So it's got sales, service, marketing, and they all have this under one unified view. So they would use marketing to get the lead, they would use sales to nurture the lead and put it through the pipeline, and then they would use service to then, so if the customer has any problems or something like that, they would be able to interact with them there. And it's all one under really nice unified view with Salesforce. So that's kind of like a quick discussion about what it is. So now that we know what it is and what it can do, how do we build within Salesforce? So it's basically coming down into two main ways of building. So you have the more clicks versus code. And so the declarative is your clicks using point and click tools. Some of them are proprietary ones to Salesforce, like flow, assignment rules, validation rules. The other one is programmatic, using more of the Salesforce proprietary coding language called Apex, which is an object-oriented programming language, and then Lightning Web Components using the JavaScript framework. There's a huge comparison chart here. We're not going to go through all of them, but basically the thing to know is that with a simple use case, we want to start declarative, and then as soon as we get more and more complex, we want to add more programmatic solutions as we go along. Perfect. So then, now that we know how to build in Salesforce, how do we think about how to build or how to design in Salesforce? So they've been generous enough to offer us something called the well-architected framework, which is going to really show us how to do these things with patterns, anti-patterns, based on the knowledge within Salesforce and the industry experts. So it's really pretty much broken down into three main pillars: the trusted, easy, and adaptable. And for our car analogy, we're going to use these to help build out our analogy. So trusted, we can assume that that's kind of like protecting people. So that'll be like the seatbelts of the car. We're going to make sure it's easy. We wanted to make sure that we deliver value fast. So that's going to be like a smooth, comfortable driving experience. We want it to be adaptable as well. And adaptability really just means growing with the business over time. So for that instance, we're going to use like USB ports in your car, right? You can use many different devices in those cars, and we could be able to use that across time as well. So this is really just how we think of like the manual of the car. So now in our car analogy, we know how to use the car, but from us to get us to London to Madrid, we need to think a little bit longer about how to do that as a journey, which is where this complexity comes in. So Ganesh, can you talk to us about that?
Sure. Thanks, Dayton. Okay, so far what we have learned is, so we have established that the car itself is robust, and we now know that it can take us from London to Madrid. But it still requires something. It still requires a prescriptive, high-level, prescriptive, single, strict architectural pattern that clearly show us the clear direction and addresses the key architectural concerns. Think of, in the analogy, it's like the route when you put it in any navigation tool from London to Madrid. It might show you multiple routes, but the one you have to choose is, and you have to stick to that, as much as possible. But having said that, on the other side as well, you have to think about, you have to keep the design flexible enough so that it evolves long term, as the journey progresses, right? So generally there are like two views of architecture. One is prescriptive and descriptive. We won't go too much into that. But the most important thing is your high-level prescriptive starts to become your blueprint, and your reality is essentially like how during the journey what steps you take. essentially in greenfield projects, the prescriptive leads and then descriptive follows. Okay, so the question still remains then why doesn't Salesforce itself prescribes a single strict prescriptive pattern? Well, the answer is simple. It prioritizes flexibility over recommending a strict prescriptive single architectural pattern. You might ask why? Because it's for very good reasons. So one of the most important aspect about Salesforce is that it's a multi-tenanted cloud infrastructure. So and it serves lots of diverse customer bases, customers. So all small, medium, large, very large enterprises all sit and all resides on that same multi-tenanted infrastructure. So now, if they start prescribing a strict architectural pattern to, let's say, which is complex, they might start losing interest of the small organizations using Salesforce. At the same time, if they prescribe something that is simple, your large and very large enterprises which have complex needs might not really, might not see value out of Salesforce. That's the reason why they have to keep it flexible. And the another reason with the flexibility is that by doing that, Salesforce itself has the, enables themselves to rapidly develop and keep on enhancing their platform so that users of the Salesforce can start solving some simpler use cases using clicks rather than code. Yeah. So having said that, then the onus of deciding that one single strict prescriptive pattern, falls entirely upon architects and developers, of the team. So, and with flexibility, you need to have a disciplined approach. So team must have to choose and apply a sound architectural principles, especially, and it's very important, especially for such complex problems, solutions to effectively serve the users. One more thing is that, with there are no guardrails that comes up, where that forces a perfect structure. Salesforce doesn't do that because of this flexibility. So it has that discipline is very important. Yeah. If we do not have that that one, if we do not have that approach, the solution or the architecture you come up with might start degrading, over time and turn into unmanageable technical debt, and you might start receiving bad reviews from your customers. Okay, so then the question still remains. Then what we do? How do we find out that one single, deliberate architectural pattern? Well, we turn to some of the industry, to the well-known principles which have been used very successfully by the industry over the years, and it has proven very successful to very large enterprises for the complex needs. So to quickly tell you about DDD, so like I said, it's all about it's an approach to deeply understand your business domain and then create that mental map. And on the right hand side, clean architecture. So if you in the initial slide we said that we need a structure, right, for our application. Clean architecture is a system design philosophy that gives you that structure. So your application can have a structure under which your core domain and your application use cases can reside. So relationship between these two, well, DDD guides you what to model based on the business, while clean architecture dictates, the dictates words is important, how you organize that model and its dependencies. At the same time, clean architecture provides the application structure, while DDD provides the methods and patterns to model the domain content within the core layers, right? So the output of DDD goes in the structure you define in the clean architecture. So one more important point, both these principles are platform agnostic. And practically, are prescriptive views of designing applications, and hence they are even applicable to Salesforce, even considering its unique platform constraints. Okay, so the main topic, the actual clean architecture itself. So the diagram you see here is by Uncle Bob. It depicts in the concentric circles, just like an onion, like a cut section of onion. The most important bits here is the inner layers. These two inner layers, they define the high-level policies and abstractions. So your core business domain, resides in these two layers, while your outer layer defines the low-level mechanisms and details of the framework itself, like UI, database, frameworks. Yeah. To quickly talk about the layers, entities. So the entities layer is where the DDD's output of your domain model, the objects like aggregate root, value objects, and even the state change domain events. This is the place they reside. And then following that is the use case layer. So use case layer is about orchestrating your flow data using the entities and achieving the application, the task which we are trying to solve. So together these two becomes your application, your core application. And then there's a interface adapter layer here. So they act like as a converter. So the data from use cases, they convert it so that your outer layer understand. At the same time, they convert the data incoming from the outer layer so that your core application can understand. Yeah, and then the outer layer is the actual framework layer itself. So if you see here, this layer has no understanding of the outside layer. Yeah. So one of the most core, defining principle of clean architecture is the dependency rule, and that's depicted with these arrows which are pointing inwards. So what it says is that it's very simple but very profound. What it says that all your source code dependencies should only point inwards. Inner layer should know nothing about the outside layer. It should not depend on it. So how do they achieve that? Like, how do we achieve that? It's using these dependency inversion principle in Solid. So your interfaces are defined inwards, like in the inner layers, and your actual implementation of those interfaces are defined in the outer layers. So the main benefits, your application now functions independently inside the framework itself, but even if it's functioning inside, it doesn't know nothing about it. So the main benefit is that you are concentrating on your application itself rather than on the framework. That way you can swap your framework or database with anything else, using this principle. The another main and very important benefit is testability. So just because your application is inside and knows nothing about this, there's no dependency you have to cater in the application itself while you're writing the unit test cases. And the last thing is, the maintainable and flexible over very long term. So this principle, the structure is very, it can evolve long term. Okay, nice. So this is the most important, probably this slide of the entire, of our presentation. So the first slide was a platform agnostic way of looking at clean architecture principle. What we have done is we have designed this diagram of clean architecture specifically for Salesforce. So, but before we come into this, I have also shown here a typical 3-tier architecture. Most of the Salesforce projects tend to use this 3-tier or n-tier layer based architecture. Now to talk about clean architecture, so all those colors which you have seen in the previous slide, I've tried to map that over exactly those ones. But the most important thing is that we now have introduced a domain layer, which is missing in this case. Yeah. To compare about these two first, you will see that all these arrows, this dependency rule, the dependencies are pointing towards the database itself. S object is the, in Salesforce, because it abstracts away your database and it gives you into the framework. Usually you interact with S objects to indirectly interact with your underlying database, right? So if you see, all these arrows are pointing towards but the most important is services layer, your business logic layer, is way too much aware of the underlying platform. And over time, it gets convoluted. But in this case, all these arrows are pointing towards your application. So essentially, it is giving importance to Salesforce itself, but here it isn't. Your S object is all the way out. Everything, your application is the most important part here. To quickly compare, to quickly tell you about clean architecture, so this, your LWC component screen flow is at the outer layer, pointing inwards to the controllers, trigger handlers, and at the same time, REST API or any other, APIs you define here is also pointing towards the inner layer. And then one more thing is the domain and your application together becomes your core business domain. Yeah. So this approach requires like a cultural thought process change, so that your team do not, concentrate on the Salesforce itself, but with clean architecture, your team basically concentrates on the application rather than Salesforce over here. So again, some of the benefits, some of the most important benefits is, we achieve this architecture using dependency inversion, and we get the most clear separation of concern is achieved, and one more comparison is that because the service knows too much about underlying framework, your test, it becomes convoluted in your test start, and you can't really achieve 100% use case coverage, and eventually it starts to become brittle. But in case of clean architecture, you can achieve like 100% code coverage and use case coverage. Yeah. So, and at the same time, it becomes very fast. Nice. So we will now talk about, we'll actually show this in code. Over to you, Dayton.
Thanks, Ganesh. Yes, I will take that from you. So this is going to be a really basic use case. The use case is we have a new contact. So what we're going to do is check the email and make sure it's unique before creating it. So email uniqueness is the primary use case concern and the policy of our application. That means that we have to implement this policy with the application layer, because that's what clean architecture advocates. The code you see on the right exactly shows this. Your policy, the policy of email to be unique is defined within the application layer along with the use case itself. The below two classes are the outer layers, showing the concrete implementation of the underlying platform. As you can see, the decouple and DML calls are part of the implementation within the infrastructure layer. So let's see what the actual code looks like here. Now, let's imagine that the user is creating a new contact from a screen flow, from the example before. The screen flow is making a call to the controller, which is this here, which is in the interface adapter layer. You can see that the interface adapter iContact repository is defined in the application layer up here. During the runtime, it's getting instantiated by concrete implementation of the contact repository of the infrastructure layer, which is right up here. Continuing with the user's flow, you can see that the use case is getting executed by sending the first name, last name, and email as parameters, as we can see right there. Now the flow that has landed in the use case, which is right here as our use case, the first thing we see is is calling the email unique policy method. Within the use case code, we are invoking the method on the interface. That call will go through the implemented method, and then we'll turn if the email is unique or not by making the required SOAP calls. So that's, again, back up here, making that call and coming back there. Once the flow is back to the use case, this is where we actually create a new contact record by coming back down here and going to the save. Finally, the save call is sending the flow of control to the infrastructure again, to make the action of creating a new contact. So again, back up here. Cool, that was a very little basic use case. Now, with the test class for this shows the power of clean architecture and clearly depicts that the test does not cross the boundary of the application layer, thus proving that your whole policy can be completely tested without any Salesforce platform concerns. Let's concentrate on the action section. As you can see that the use case call is only dependent on its own layer. So right here we have the action, and it's only on this use case action layer. Lastly, you can see that the arrange part, which is underneath that, shows how we are passing the mock to create the contact use case as a concrete implementation of the interface. Lastly, you can see how the unit test code is a pure representation of your case or unit test case. Off to you, Bunny.
Yeah. Okay, so, that essentially, the simple basic use case essentially proves that we could actually have clean architecture principles even in Salesforce. But let's try to understand, even further with using an actual advanced use case. Especially that is something which we often see in Salesforce, in a complex, with some complex use case. So this use case, when an opportunity reaches a closed won stage, it's doing multiple concerns. It has to update a contract. It has to generate an invoice PDF. Probably it has to even create that PDF. And then notify the finance team via the state change platform event. And then there's one more rule, if everything is successful, then only go and update the external ERP system. So now, as you can see here, there are many multiple concerns our use case has to handle. So there is database calls to get the opportunity save or create contract invoice. There's a file generation involved. There's an asynchronous event involved. And then finally, there's an external call out that has to happen. So clean architecture really separates these concerns into their own layers. And at the same time, the whole code becomes quite clean, and it ensures that it delegates the concerns into their respective layers. So quickly going through the code, key components, you can see that this is the use case code, and we have, it depends upon the interfaces which are essentially defined within the application layer itself. But there are these multiple interfaces, and at the last there is also a unit of work pattern interface that has been defined here. So, and then all those interface actual implementation they get dependency injected via this constructor during the runtime. Now let's look at the execute code a bit. This is an actual code, pretty much the entire code, even for that complex use case. And you can see that it does 6 different activities. So it gets the data, and then it starts its core logic of creating the contract from opportunity, then a new invoice, then it's creating this platform event, and then it is registering all of that in the unit of work. And then over here, we can see that it is also generating a PDF file. And then finally, it commits that work, using the unit of work pattern. Now, if everything is successful, if that commit work is successful, then only it goes ahead and makes that external call to the ERP service. So you can see here that, all of all the concerns, it delegates away to their respective implementation, concrete implementation, and without even understanding about those external layers much. So further, one more topic here, like clean architecture, aligns well with the with the enterprise, with the Apex enterprise patterns as well. Basically contributed heavily by Andrew Fawcett. I highly recommend this book. It's a nice book for anybody using Salesforce. So what is Apex enterprise patterns? It provides you different, it provides you libraries and something and layers that you can use. And with clean architecture, you can organize that into a very into a very robust and maintainable structure. Yeah, and then essentially, basically, you get a prescriptive structure rather than not having that one prescriptive approach to follow. So this is very quickly the code example. We'll not go through that, but the most important thing is the application, this class. So the Apex Enterprise, in the Apex Enterprise pattern, this is where you set up the whole application. Yeah. Here you can see that we are making a call to this get use cases. It is giving you the use cases, actual use case when upon a trigger handler, and it is calling that execute. So yeah, so rest it delegates to the use case. Over here also we are showing another example with account service. Here you can see that the application is now getting it as a service, but it's still getting that use case and then making call. So yeah, it essentially proves that clean architecture is not, it's not something complex to achieve in Salesforce. By using Apex Enterprise pattern, you can quickly achieve clean architecture approach even in Salesforce. Yeah, with that, we have covered a lot here, and yeah, if we have any time, we can take some questions. Yeah.
Is Apex only used exclusively with Salesforce, or is it a language that's used?
That's a good question. So it's a proprietary language of Salesforce. So no, you can't use it outside. But essentially, it takes a lot of inspiration from Java, and even the syntax are pretty much like C#. The important bit, like Dayton mentioned, it's still an object-oriented language, and it is a strongly typed language, just like Java and C#.
Yeah, I was going to say it looks really like Java.
Yeah.
What's the with sharing? So just to follow up, I saw that with sharing.
Oh yeah, so another good question. So that's more about security. Like, so whenever an action is invoked, the user under which that action is invoked, that with sharing ensures that it it keeps on delegating in the inner in the downstream applications. So if any downstream application do not have this, if this user do not have permission, it ensures that this permission flows. So yeah, so that is about the security part. Yeah, go ahead.
So when you're running these systems or developing these systems, do you develop against just the interface, or do you actually have an instance of Salesforce running in the background that you can locally dev against?
So when you develop towards the interface, I didn't get the question.
So when you're working on this system, do you actually have an instance of Salesforce running in the cloud that you develop against, or do you actually say, I'm just going to take this opportunity to use the interfaces and mock out the actual bits which we want to do?
Yeah, so Salesforce is slightly different than other cloud platforms. Essentially, like I said, it's a multi-tenanted application. So when you start using Salesforce, you by default get something pre-built. It's like your car already have like lots of attachment that comes up along. So yeah, you essentially it abstracts away the whole cloud infrastructure and you only build inside Salesforce. So it gives you all the mechanism just like you do in any other cloud. It has your, it provides you Visual Studio, like extensions in Visual Studio Code. It has its own developer console. So you basically write inside that interface, within the Salesforce. The another point is that there is a Salesforce developer experience, CLIs available, by which you can also have like CI/CD pipelines built for Salesforce. So yeah, it essentially gives the same developer experience as you get with other technologies like languages, but essentially it abstracts away many underlying cloud concerns in the framework itself.
Well done. Great. Thank you,
Yeah.
Ganesh. Thank you.
Thank you.
Thank you, guys.
Hey, straight away. So thank you again to our speakers. They put a huge amount of effort to not only be here tonight, all three of them have come from London on their own money, taking time out of their work life to come here to put those presentations together, to spend the evening with us. It's a huge amount of work they put in, all for free. So thank you very much, both you guys. And for Paul, who's had to go home again. Thank you also to our volunteers, which we had Kerry tonight. Thank you. She doesn't get a choice. She's my wife. Thank you also to our supporters, Reconnect Conference, which I'll come back to in a minute, Just Pick One UK, and Bournemouth University. Thank you, Finn, and for all the department for allowing us to be here tonight and for the next couple of sessions as well. And without them, we wouldn't be here tonight, and we probably would all be at home watching TV instead. I just want to remind you about all the different ways you can contact us. And as I always say, contact us means contact me. So if you want to be a speaker, a volunteer, or even find out like the local tech events, you can find all these things. If you join our Discord channel, please, we've got about 15 people on there now. It's kicking off again. You can find out information about these events quicker. I'll be starting to put more information on Discord as our first point of contact going forward, because LinkedIn is very slow at telling you about new things. It could be 2 weeks before you see a post from today. So we'll start be using Discord soon, and I haven't spoken to Asimi yet, but we might even use that for Reconnect. Well, she didn't flip me off, so that's a good idea. So while I mentioned Reconnect, so Reconnect Conference is 71 days away. And it's a big tech conference here in Bournemouth at the Vitality Stadium. So if you want to come see where AFC Bournemouth actually play, we're going to be in the stadium where they play. So you might even see a footballer on the day if you recognised any of them. I didn't. There's 4 tracks, there's 17 speakers, there's 7 workshops. It's a huge venue, and we're hosting over 200 attendees. We've got things being filmed. We've got podcasts. The podcast people are over there. Thank you. Media partners. There's so many people involved in this, and it's a big deal. So if you want to come, there's 10% discount over there, dev.talk. Which you can use. It costs a whole £64 and a day off work. So please come. If you bring a friend, perhaps we might be able to find you a bigger discount. Who knows? There's not actually very many tickets left, so I say that. I don't actually mean we've got any space for them. But so the other thing is, do you want to volunteer at Reconnect? If you do, there are some things that you need to do, such as sign your life away for 2 hours for the day and help out at the event. And if you do choose to do that, you can have a free ticket for it. Or you might want to come help at dev.talk. You can come set up a camera or welcome people in at the door. All volunteers will be helpful. Speaking of dev.talk, the next event is May 21st at Bournemouth University. We're going to be across the courtyard next time, apparently, in the Fusion building, which is a cool name. It's a nice building too. So we're going to be over there, and we've got a talk on open source AI, and somebody also talking about trying to break into tech from a different industry, which is going to be an interesting thing. as well. But yeah, open source AI is kind of the highlight, I think, for that. Again, somebody not local. We're getting lots of people who want to come in from London to Bournemouth, which is nice. Sorry?
They come back.
Well, hopefully they'll come back for Reconnect, George. I'd just like to point out all the other local tech-based events. There's a whole bunch of them. These are all listed on the website. It's a brand new one at the bottom called Developer South Coast, which is down in Southampton. I went down there last week to a talk on AI, on LLMs. It was really interesting. I'm trying to get that speaker to come here. He's a very good speaker. But Developer South Coast, just down the road, 45 minutes away by car. I also want to tell you about this brand new event. Literally, we've just put this together today. So dev.talk and Reconnect are going to host like a mixer event, a networking event, just before the Reconnect Tech Conference. We're going to be at Patch on June 25th, again in the evening. Tickets will become available probably tomorrow. Yeah, probably tomorrow, as soon as we've got some, I think, confirmation in place. Free event. There'll be a bar there. We're not paying you. Have to buy your own drinks, sorry. But it's a mixer event to come and meet other people from the industry, and also perhaps you might bump into a speaker from the event. You'll certainly bump into the organisers of the event and come talk tech. We're even thinking about having a quiz on the night, although I'm not entirely sure on what. Oh, I was hoping it'd be on like Lego or something. So if anyone got any ideas on what the quiz could be, or yeah, yeah. So we'll do something on the night as well. So come along to that. It's free. It's in Bournemouth, just down the road for the two of you from not local. Patch is a lovely venue. It'll be about 100, 125 people there. So it'll be good to mingle with lots of people, and a free event as well. And that's it. So thanks for coming. It's really good to see everybody here and to see that we're hitting a wider audience. And apparently Flagstone are our brand ambassadors today. We got several people from there today, entirely unintentional. But check them out. Sure, why not? I'm not quite sure what they do, but sure, why not? If you want some money, they do fintech things. Money. I'm sure they've got some. And that's it. We're very nearly out of time. We can probably do about another 10 minutes, 15 minutes of networking while we pack up around you. And we'll make sure everybody's out the door by 9:30 at the latest, because Finn wants to go home. And
I probably will go home, but you'll be fine.
Oh, okay, fine. Cool. We can always talk in the corridor instead. Great. So thank you all for coming. I hope you have enjoyed the evening. So give yourself a round of applause. Cool.